Okay, so Kafka administration. Okay, so Kafka administration is all around the field of data, moving data from source to destination. That's all this Kafka is about. So these are not these are not data analysts or anything. Data analysts, they do their own thing. I don't really care much about what they do. But my job is to get data from source to destination for them. So now, traditionally, Kafka is also new. I think Kafka is much more new compared to DevOps. Kafka should be like 4 years, 5 years, then DevOps should be 8 to 9 years now. So before the advent of Kafka, this was what was happening. So an organization, we can have our website, which we have deployed, like the DevOps and all have done their shit. Sorry, have done their stuff, and then they've deployed it. They've deployed it to production and it's here live and everything. Our website is here live, and then website keeps feeding us metrics. Like if this is a shopping cart, like a shopping website, e-commerce website, then, for example, we can have customer orders, data of customer orders. We can have data of payment. And if this is a bank or something, for example, we can have account creation. We can have debit data, debit alert data or something. We can have credit transaction data and everything, right? Now, this is your website. Everything cannot be hosted on your website. Every functionality cannot be hosted on your website. So that's where the picture of what is called like the database and other form of backends. That's where the picture comes in. So let's say we are now having multiple forms of backends or processing. Here, let's have this. Okay, let's have something like this. Okay, so for some of us that may have experience on how a traditional website and back end works, is this application now, this website would traditionally talk to a database. So putting the putting the information in the database, that's fine. Yeah, it will talk to a database and put the information in the database. So this is database. So it will send information into the database. We can have multiple databases, like different type of database. This one could be Postgres. This one could be MongoDB. So yeah, different databases can send the data that is gotten from here. But now, traditionally before, There are now tools that need the data. There are some tools that we use in the organization that also makes us be able to like perfect the operation side of running a business. Like because a company is also a business, right? So here can be metrics management. Here can be metrics management tool. Here can be data warehouse where we preserve all our data in a location of in case this in any event where this one crashes or this one crashes or anything. So we can have a data warehouse, and maybe this one is notification system whereby like after a customer makes a purchase, how do we know before we notify them saying, thank you for the purchase, your goods will be shipped out shortly, or those kind of like retargeting notification that happens to us when we visit some website and maybe we make some purchase. So let's just say these three tools, for example, that other part of the organization, like the management team and the rest, they need, or for whatever reason that they need. Like for a bank, fraud detection. How do banks detect fraudulent activities? It uses this kind of moving the data from one point to another. They can be a tool in an organization that has been designed to detect fraudulent data. Now you need to move the data from your database into that tool for that tool to catch that fraudulent activity. Does that make sense so far? So it's like, how are we going to be able to move data from this database or from our application, depending on anything? We call this place the source. How do we move data that are in this source and put it into anywhere that we want to put it into for us to get other functionalities out of it? Let's put one more example. Let's say AI model, because Netflix particularly uses Kafka. If you want to browse that, they are a major customer to Kafka. So like AI training, because AI are trained using uh, data. So how do we move data into this AI tool to train our AI model with our data? So all this now, how does data move from this source to this place? Before the advent of Kafka, they have to build something like a straight line. They have to build a straight line. So let's simulate a straight line. A straight line from here to here, if that place is needing the if it's needing the information, a straight line to here, straight line to here, straight line, straight line everywhere, right? Straight line to here. When it comes to this, straight line to here, straight line to here, and all and all. So how many of you begin to see how complex this is looking? This is looking very complex. Before you know it, like in an organization where we are having multiple data movement, you, even as, I don't know whoever manages that, but whoever is managing that will feel very overwhelmed. Will feel very overwhelmed with such such movement of data, and then it is very fragile. Such movement of data like this is very fragile. Let's say something breaks here, and then this connectivity is no longer there. We now have to troubleshoot. We have to come and trace it. Then we have to try to build the connectivity again from the database into this place. And then this puts a lot of load on the database, because It's called PubSub. Uh, 10 years ago or so, we call it PubSub. PubSub. PubSub means publish and subscribe. Publish and subscribe. So it can be designed that this database will need to be publishing the data to this point, to this destination, publishing it. That's a lot of workload on this database. It can cause it to crash, or we can set it to subscribe, that this tool needs to subscribe to this and that. Now, there are certain of these tools that may not have that functionality. Now, this is a warehouse, but this one, for example, Snowflake, the one that I've interacted with, Snowflake, is a warehouse, but it does not have the functionality to subscribe by itself. You need to push to it. So let's say we have 50 different destination points that does not have the functionalities to subscribe. They need to be published to. Then we are putting a lot of workload on our database. So also, when something fails, it's difficult to track it. You may need to pull this down for temporarily for you to now look into it. And if you pull this down, then there are other connectivity that is other sources that are connected to it. All being a straight line is very daunting. It's a crazy thing to have. Also, the one more issues that they used to face back then is the pops up method. If the database, like for example, if they use a tool called MQRabbit. MQRabbit was a tool they were using for this PubSub. They can use it to try to connect it one line at a time. If you consume the data from the MQRabbit and send it to this warehouse, that data is lost. Let me put example MQRabbit. You can browse something like that just to read up on it. So MQRabbit, this tool, if I put data from the database into the MQRabbit can do the PubSub. It can connect to the database and subscribe by itself, subscribe to the database, and then it can publish it to this warehouse. So I'm giving you two scenarios of what used to happen in the past. First, they try to connect the database to the destination directly, which is very, very bad. It breaks a lot of time, puts a lot of load on the database. Then they graduated into PubSub. Then PubSub uses tools that are not so good. They use tools like the MQRabbit. So the MQRabbit can do the subscribe to the database, picks it up. Let me kind of put a flow. So it can actually subscribe to the database, picks it up into its queue. I hope, let me remove this. Let me use this. So you can subscribe, put it into its queue, put it into its queue, and then it can send it to this destination, right? For example. But now, once it takes it, let's say the data is A. Once it takes it, and then this destination has subscribed and taken the data, and it lands in here, the data is no longer in the rabbit queue. It's no longer in this rabbit MQ. It's no longer in there. Now, let's say this application also needs this same A data. Then you need to create another rabbit MQ application to also pick up the same A and put it here. Because whenever any destination consumes the data, it is lost from the MQ rabbit. So you see that this is not a very perfect system. This is a flawed system. So recently, Kafka got introduced into the market, and there are not a lot of admins for Kafka. I think the Kafka is even much more sorted after compared to the DevOps. I'm currently a full-fledged Kafka admin at my organization. Okay, so now we'll explain how the Kafka comes in and revolutionized everything. Let's push this back a bit. Okay, so now Kafka will make Kafka like a box. So Kafka. Now, this is how Kafka comes. Kafka sits in the middle of everything. It sits in the middle between the source and then the destination. And this is how perfectly it does its job. So now the database can send multiple data into Kafka. Just connect our application if at all we are moving data from our application directly. They all will connect to Kafka, right? Send the messages into Kafka, and then as multiple destination as we want can get the message from Kafka. After drawing it, then I begin to explain the advantage. Okay, okay. So yeah, this is the Kafka, and this is how it makes it very, very clean and easy to now move this data from source to destination. Now, the advantage and why the Kafka is much more better than other traditional in the past examples that they were using, tools that they were using. One, this Kafka is made up of topics. We call it topic. Now, topics, you can create billions of topics as you want. So we can say topic is just like something like this, something like this. You can create multiple as much as you want inside the Kafka. So each form of data goes into a topic. Each form of data. So you create topic, you delete topic. There's no limitation to the number of topics you can create. Now, this database can send payment data into payment topic. It can send purchase data into purchase topic. It can send different type of messages and data into dedicated topics specific for that type of data. Then the destination side can pick up the messages and it will not get deleted. So the message A, for example, is in this topic, and this one can consume it and it will still remain in this topic until you come and delete it from the Kafka. It will remain. Why? See the advantage now. A consumes it. This consumes the A message. This one consumes it. This one, if he needs it, can come and consume it. This one, if he needs it, can come and consume it. This one, if he needs it, can come and consume it. Now, not only that, this one consumed it maybe today. It can decide to maybe need it tomorrow. We don't know the crazy things that can happen. Just prepare your mind for any use cases that we call them use case. Any use case that can come up in the organization, they can reach out to you saying that we want to always get the data every 1 week. Now, when you say you want to always get the data every 1 week, Kafka solves that, gives you that solution. Kafka gives you that solution by being able to allow you to get the data even after a week. You come and you see the data, and every source, as long as they need the data, they can connect to Kafka and get the data. So Kafka sits there and give you when you need it, collects when you want to send to it. So also, this particular destination can consume multiple topics. So this one can consume from, let's say, three topics, meaning three different data. For example, now it wants to, let's say, where's our fraud detection? Maybe, okay, yeah, metrics tool also pull different data together. So if it's a tool that needs to like work with different data and do some manipulations on the data and all, right? It uses the Kafka. It can connect to this topic A. It can connect to this topic. We'll call it maybe uh, sales data. We'll call it refund topic. We call this one successful purchase topic. It can connect to multiple of the topics, pick all the data at the same time, then be able to do whatever manipulation it needs to do to be able to give us a management dashboard whereby we can say, oh, towards this period, today, we got a lot of refunds and we got a lot of purchase, or begin to see trends in the organization. So whatever you can think of in terms of like just opening your imagination to the flow of data in an organization, Kafka is the best tool in the market right now that does that implementation for them. Like a bank that wants to do fraud detection, then admitting others into the meeting, then we can start. I think we'll just run for the next 20 minutes. Sorry for exceeding the time, and then I'll be able to round up. Okay, so maybe we can continue, we can proceed. So you all can see my screen, right? Okay, I'm just picking up on the chat. Chiwendu. Okay, Chiwendu is still with us. So I'll do a recap at the end. I'll just try to do a recap as much as I can. Okay, all right, let's proceed. So yeah, there are different use cases. I was making mention of a bank that have like done a short time project with them on this Kafka. They needed to build a fraud detection model that will be able to detect fraudulent activities. I think theirs was based upon any transaction above $10,000, it needs to be picked up and blocked for further review before it can be processed. So for you to quickly take that data from the database and then send it to the application that uses it, because the application that would detect the fraudulent activity is different from the application that authorizes the transaction and sends it and allows it to go to the destination account. So it needs to pass through Kafka, and then if it picks it up as a fraudulent activity based on its design, based on its parameter or its model that it has been trained on, it can quickly send a notification to block that transaction for further review before it gets to the recipient of such transaction. So yeah, Kafka is relatively new. You can Google Confluent Kafka. So Kafka is relatively new. It has functionalities as well. It has functionality as well, whereby you can, depending on the use case, they can say, right, watch this closely. They can come, someone from the operations team, not operations on the DevOps side of things, but someone from like maybe another type of team, maybe we can say payment processing team in the organization. They can say, hey, we need to merge a data from MongoDB and Postgres. We want to merge both of their data together, and then MongoDB traditionally holds um, data like pictures, videos, all those kind of data. They are called unstructured data. Unstructured data, MongoDB holds it. Why Postgres is for structured data. Structured data like customer name, customer ID, items that was purchased and all. But let's think of a use case whereby not only that the customer purchased, let's say, a pressing iron, we want to send a notification with the picture of the pressing iron as well. So we need to get the picture of that pressing iron from the MongoDB and then merge it with the data that is coming from the Postgres into our notification system so that it can push that notification to the person. So Kafka has the functionality to be able to bring bring the data. The data from Postgres will go into Postgres maybe topic, and then the data from Mongo will go into Mongo topic, and then inside that Kafka, you will blend the Mongo topic and the Postgres topic. You blend them into one topic. That is, they are still there separate, but then you merge them and create a new topic out of the two of them, and then that topic will serve as the blend of MongoDB and Postgres data. Then you can push it. So it's like, think of any use case that an organization would need for moving their data. You are the one that is gonna um, help them out. You are the one that is gonna sort out the solution for them. So what are the caveats? If you're interested in Kafka, it's fairly much more simple and straightforward because it doesn't have many tools you need to learn. It's just the Kafka itself you need to learn. DevOps, DevOps has a lot of tools. So I was saying that now comparing the two, the DevOps engineering, it requires a lot of tools. I can say like 6 to 7 tools, really, you need to learn. And then the Kafka, not much tools you need to learn. Like you just need to understand how Kafka works and what are the things you should do, what are the things you can't do, what are its limitation, right? Then for a DevOps engineer, you will not face a lot of questions in terms of like, how do we do this? How do we do this? Most organizations may have their DevOps set up and all. You are just there to create more pipelines or maintain the pipeline. Like they may have a DevOps guy that built a pipeline that is always crashing or the pipeline takes too long to run. Then you can come and try to uh, redesign the pipeline to make it faster or something. But for the Kafka, even I struggle with this currently in my organization. No one really knows the Kafka. Management doesn't know it. Uh, Almost everyone is new to the Kafka. So everything needs to come from you. Every idea needs to come from you. So traditionally, you see something like, hey, we want to do this. We want to move the data from Postgres, but the data is coming as JSON. It's coming as JSON format, but we want to change it to CSV format. Can Kafka do this? How can we do this? You need to go into the meeting, try to see if Kafka can do that. That's if you already know. If you don't already know, you need to go do your research if Kafka can do that. You try to make, give them the solution. And there are different, trust me, there are different use cases these guys can come up with for their data. They can say, yeah, one usual use case is like for a bank, they will say that, okay, credit transaction is flowing in, but we want to redact the pin so that the pin is not the pin, like the pin of the person of the account is not flowing around in the organization, right? So you need to find a way in Kafka. That is actually very possible in Kafka. You use a tool called KSQLDB in Kafka. So Kafka has like three tools with it that it uses. We are gonna be going deep into it, but yeah, you can use a tool to now redact it, whereby when the message comes into Kafka, then we will use a query to drop that field. That field, which is gonna be like account pin, you will drop that field before you send the message, maybe before you send it to the fraud detection system. The fraud detection system does not have any business with the person's account pin, right? It doesn't need it. So why do we need to send the entire data to the tool so we can redact unnecessary data that the system does not need, and then we send it to that system so that they are robust things. You cannot phantom, you cannot be able to entirely know what are the use cases that they can bring up to you, but just know that in entirety you have a responsibility to help them flow their data into their destination for it to do, like if they want this A to come into their destination but slashed or changed into from capital letter A to small letter A, you need to find a way to help them achieve it in the Kafka, as a Kafka admin. And if what else did I want to say? Like the Kafka itself, your job is to make sure this doesn't crash. You make sure this is up, this is robust, this is having high availability, this is reliable. We are not going to wake up today and log into work and see that Kafka is down completely and then messages are stuck between producers and consumers, source and destination. So these are your responsibilities. For DevOps, it's also your responsibility to ensure pipeline is not crashing. We don't wake up and be like, oh, the pipeline is not working, but then might not be too much of a headache for you because pipeline is really when they are ready to run it, they run it. But for Kafka, Kafka needs to be running 247 because you are not manually sending the data into Kafka, you are not manually pushing the data out of Kafka. So everything is working as a flow. So why we started this class, since if you have a Kafka environment, messages are flowing in and flowing out, messages are flowing in and flowing out. It keeps working like that. So that's a recap of what the DevOps engineering is and what the Kafka engineering is as well. So we can just do a recap to understand why a lot of people don't know this. Like a lot of people, really, if you get introduced to tech, you have saturation in the niche of um, developers. Everybody is a coder, everybody is a developer. That's because it is very easy to start with. It is very easy to become a developer. It is very easy to become a developer. You hop on your YouTube and you type Python tutorial. All you just need to do is have a laptop, have your Visual Studio Code, and then you can begin to practice Python script, writing Python and rendering it. So it's kind of like the barrier to entry is very minimal, right? It's just your data and your YouTube. So that's why a lot of people end up being developers. But now it's a saturated niche, to be honest. Not much organizations looking for developers anymore. So this DevOps, why it's not something you see a lot of people doing is because of this limitation. This limitation where I showed that we need to purchase server from AWS. We need to purchase server from AWS. So AWS cloud provider and server. So now, for example, you're learning DevOps, you want to practice DevOps. You want to have this server, you want to have server to simulate UAT environment. You want to have server to simulate production environment. You want to have server where your CI/CD pipeline will run on. They are being the cost is on being I think billed in dollars, and not even that Nigerians can't access open AWS account. I tried. I don't know if it has changed, but Nigerians can't because our bank card cannot open uh, does not authorize them. So when you want to open an AWS account, it will require you to authorize them to remove $1 from your account to verify that the card is working. But your bank will reject it. Nigerian banks don't allow such stuff. I went to the bank, complained. They said it's all this online like cheaper cash card you can use. Tried opening a cheaper cash account, it didn't work. So those are the limitations. Like if you do open the AWS account, then you're gonna be charged. Let's say you do practice with this server for like a month, they charge per month. You might get a bill of like $200 coming to you per month. That's over like 400K. I don't know. Like so it's kind of like how do you pay such an amount? So that's the drawback. And then the Kafka as well. This Kafka, it comes up in terms of like brokers. Brokers, it's there's what is called broker, and the broker traditionally they run on servers. So we can in an organization why we have our DevOps production server, this and that, we can also have servers that are dedicated to run Kafka. So that's like the drawback that makes it very expensive even when you want to learn from um, traditional classes courses. You see them taking the course for about like 700,000, 500,000, because they will be needing you to create these servers and maybe paying for the servers, right? But yeah, one of the reasons why I created the course is because I kind of like I'm someone that just spin around and try to see what I can do and create. So I created an application that actually helps us to create these servers, not really needing to use AWS and all. So, what am I trying to let you understand is simulation. Learning a course is simulating it so that you can confidently talk in an interview that, oh, this is how it works. This because they are employing you because they need you. If they know it or if they can do it, then they wouldn't need to employ you. So you need to know first off, you have that value there. That's why they are needing you, and that's why they are calling on you, employing you. So all you need to do is whichever way you use to practice it and know these things, then you go in there and then you perform the or what is needed. Nobody's gonna hover around you saying, "What did you click? How did you do it?" No, they don't do that in the work setting. You do whatever you know how to do, and all they need is it done? How if it's done, then you show them the demo that this is done, the pipeline is working, and all and all. They leave that to you because that's your role as the DevOps engineer. So I'm trying to spin up the tool, the application that I was able to create to use a way to create servers and the rest to do practice. And after the tech for dev stuff and the vibe coding, seeing how it kind of levels the playing field to learn how to code and how to do tech. For some of you that I kind of met with you from Tech for Dev. So I was like, for this DevOps and Kafka, perhaps this is a tool that can also level the playing field, whereby you can be able to do your practice without needing to incur those costs of creating a server on AWS and all. So let me spin up the application 1 minute, and then I will just show it. Then tomorrow we can look into it deeply and see, maybe do one or two test practice and really show you some of those building an application, testing it and rendering it, seeing it, changing it, test it, render it, change it, test it, render it. We'll do all those tomorrow and see. So, okay, just give me a few minutes. All right. So that by my
Can
picture.
see it.
Yeah. So I just try to like play around with it. So this I've been using it to practice for a while, just putting any password, not really having it protected. Then this is the interface. So like this, these are virtual machines. The server that I talked about, these are like the servers. You can create it like a simulation, right? You are creating this free type of server, but in your mind, you know that this is like a simulation of AWS server, like a simulation of a server from AWS and all. But this one, you're spinning it on your local computer so that you spin it at any time, 12 midnight, anytime. You don't need to pay for anything or anything. So these are database, Postgres database that I talked about, Postgres database, MySQL database, MongoDB. So you don't need to go into AWS. If you spin up MongoDB database on AWS, that you need to do all this practice, you want to do an end-to-end practice, that's costly, man. You're gonna have to spend a lot of money just to learn and apply as a junior DevOps engineer. So this is Redis. You can have all this and play with it. This is Jenkins. This is the DevOps. Do you see DevOps tools? See what DevOps tools? This Jenkins is the CI/CD pipeline. This is one of the two. This is extensively what you are going to be using as a DevOps engineer. You are going to create pipelines using Jenkins as a tool. Also GitLab. GitLab is also another tool, so that if you get employed into an organization and they are using Jenkins, fine, you already have an experience with Jenkins. If they are using GitLab, then fine, you have an experience with GitLab. I've never used Jenkins in the work environment. I used Jenkins when I was learning, but in my current organization, we are using GitLab. So GitLab is what we are using in the organization. SonarCube is for testing. We'll do in extensive tutorial tomorrow. Portainer is something for management of containers and all. Nginx is load balancer. We can understand the concept of load balancer later on, but I can just explain it. Load balancer, for example, you have like three servers. When I told you that an organization that has a lot of money can have three servers for their development environment, they can have three servers for their UAT, they can have three servers for their production. Now, when you have three different servers, you will run your application on three of them, the same thing on three of them, but you don't want to imagine having three different URL just to reach Google or just to reach Netflix. That doesn't make sense. So you're not going to hit www.netflix1.com, netflix2.com, netflix3.com. So they will give you one central URL, www.netflix.com, but when you hit it, at the back of it, it is going to route it to any of the servers so that the load is not too much on one server. So if Sunday, someone called Sunday, Precious, any of us from the class is hitting Netflix, you rest assured all of us are not going to be hitting the same server. At the back of that URL, it is going to reroute it to different, let's say they have 50 servers, because I mean a lot of people log into Netflix per time. So they can have up to 50 servers, but they have that one central URL called the netflix.com, and then when you hit it, it will route behind it, take you to server one, take another person to server 20, just to distribute the load so that the load is not on one server alone. If you have too many traffic, too many people hitting one server alone, it's going to crash. So those are also designs that you need to understand. But operations teams, they know all those, so they actually do those. The operations team, they know how to do all those things. So yeah, and Kafka, this is the Confluence Kafka. Can spin up the Confluence Kafka. These are all the things that are. So it's like once you just click, it will spin it up. I don't know if I want to quickly do an example, but I think we'll have enough time tomorrow. I've taken a lot of your time today. So yeah, this is what it looks like. And give you a little bit of walkthrough, then I can distribute it for you guys to learn. I was really hoping we have a lot of people in this class so that it helps a lot of people, but that's fine. That's okay. We'll do what we can do. So yeah, let me know if any question. If anyone has the recording, like recorded it, could you please share with Chinwendu? Maybe you could drop your email in the chat. They could share it with you, and then you wouldn't need a recap. You would be able to just get the full class of what we discussed. I guess we really went in details this class, so you would need that. So yeah, any questions, let me know. I think it's a wrap for today, but let me know if you have any questions.
Okay, thank you so much, sir, for the class. Can you hear me?
Yeah, you're welcome. Thank you. You're welcome.
All right, am much more interested in the Kafka administration, and I I don't know this last platform you shared. Is it a learning platform
Yes, a
that
learning
we just
platform.
plug in to learn those things?
Yeah, learning platform. Yeah. So spinning up those servers, spinning up database so that like for the Kafka, whoever is learning Kafka, right? You want to practice moving data from Postgres database into Kafka and sending it into a destination. So you spin up the Postgres database, you log in into it, send some data into the Postgres database and watch it and see if you are able to get it into Kafka, right? So you need to make those practice. Extensive practice is what you need, and you build your resume. Once you're able to do it, just go to your resume, put it down there, moved, like orchestrated, you use big grammar, right? Orchestrated or designed a Kafka flow or data stream flow, moving critical data from Postgres database into Kafka and into destination, whatever destination you're using. So once you practice and you have that success, put it in your resume. Those are what you share with them, and you wouldn't be that you're lying. It wouldn't be that you're telling them what you haven't done. So whatever you have in your resume is what you've done, right? So yeah.